We're going to finish this section by looking at a couple examples. The first one says a 14-ounce box of cornflakes is $2.66, and the 1 pound 2-ounce box is $3.42. Which size box is the better deal? A lot of times you go to the grocery store and they'll have the stickers with the prices, and they will also give the price per pound or the price per ounce. So if you're trying to find the best deal, you can look for which item has the cheapest price per unit. In this case, we're given a 14-ounce box and then a 1 pound 2-ounce box. So the first thing that we need to do is get our units to be the same. So what I'm going to do is I'm going to take that 1 pound 2 ounces and convert it to ounces. A pound is 16 ounces, so 1 pound 2 ounces is just an 18-ounce box. So we're comparing a 14-ounce box and an 18-ounce box. To find the better deal, you're going to divide out the price per ounce. So for the 14-ounce box, you'll take that $2.66, divide it by 14, and I will be rounding these to the nearest penny, dollars and cents here. And then when you divide this out, you're going to get 19 cents per ounce. We actually call this a unit rate because it's over 1 ounce. For the 18-ounce box, do the same thing. Take the price, divide it by the number of ounces. And when you divide and round, you're going to get the exact same amount, 19 cents per ounce. So in this case, which size box is the better deal? They're exactly the same. Depends how many cornflakes you want to eat. The last page, we're going to do one more example, and got a definition here. If we say that y is proportional to x, we can say that x and y are related by this equation, y equals k times x. K is called the constant of proportionality. Let me give you a for instance, actually using the last example with pounds and ounces. A pound is 16 ounces. So if y represents pounds, actually, let me redo this. Y will represent ounces. I don't want to have a fraction for k. K would be 16 if x is the pounds. So the number of ounces is 16 times the number of pounds. It's called a constant of proportionality because if you're dealing with ounces and pounds, that 16 is never going to change. There's always 16 ounces in a pound. If I had switched the pounds and ounces, and you might see here why I decided to rewrite this, you'd still have K, but it would be a fraction. It would be 1/16. I think it's a little bit more straightforward to write it as the whole number. But that's what a constant of proportionality is. So we're going to look at this example here. It says the flagpole at Sunnyside Elementary School casts a shadow 9 feet 8 inches long at the same time that Mr. Shaw's shadow is 3 foot 2 inches long. If Mr. Shaw is 6 foot 3 inches tall, how tall is the flagpole to the nearest foot? When we say that two things are proportional, we can set up those two fractions. And what you're actually finding, so as mentioned with the definition, is the constant of proportionality. A lot of times we don't see that constant of proportionality per se when we're solving the two fractions that equal to one another, but it's found by dividing out one of the fractions. Let me show you what I mean here. Before I set up anything with fractions, I want to put everything in terms of inches just to keep it a little simpler. So if the flagpole has a 9 foot 8 inch long shadow, to turn this to inches, just take 9 times 12, that's 108, plus 8, so that's 116 inches. Oops, there we go. Mr. Shaw's shadow is 3 foot 2 inches, so that's going to be 38 inches. And then it says Mr. Shaw is 6 foot 3 inches tall. 6 times 12 is 72, plus 3 is 75 inches. So I'm going to set up a proportion, and I want to show you where this constant of proportionality would be found. You can set up the proportion a couple different ways. What I'm going to do is I'm going to do the heights in the numerator and the length of the shadow in the denominator. So I'm going to start with Mr. Shaw, the teacher. He is 75 inches tall, and his shadow is 38 inches long. The flagpole, we do not know its height, so you can use a variable there. If you want to use H for height or T for tall, whatever makes you happy. I'll use an H for height. We don't know that, but we know that its shadow is 116 inches long. In this case, the constant of proportionality would be 75 divided by 38. When we solve these as proportions, a lot of times we don't divide that out straight away. We'll go to the cross multiplication to solve it. But just in case you're wondering, where's that constant of proportionality fit in? It would be 75 divided by 38. But I am going to solve this with cross multiplication. So 75 times 116, if you multiply that, you get 8,700. We'll set that equal to 38 times H. Doing a little bit of algebra here, we'll divide both sides by 38. So that gives us a height of approximately 229 inches. And if you divide that by 12, it's going to be about 19 feet. Like I said, if you wanted to first find the constant of proportionality, you could take 75 and divide it by 38, then multiply by 116, it'll give you the exact same answer.